All equipment is to be considered as energized unless it is tested and verified as otherwise. And if work is to be conducted on de-energized equipment, then depending on the circumstances, a lockout-tagout procedure may be required to ensure that the equipment remains in a safe working condition all the while workers are potentially being exposed. A typical lockout-tagout procedure involving multiple workers usually involves establishing a safe work condition based on the following steps: preparation, shutdown, isolation, application, controls, and verification. Once a safe work condition has been established and verified as established, then the work phase begins. Now, it's to be understood that a lockout-tagout procedure is not the equivalent to nor a substitute for a pre-job. The lockout-tagout procedure is used in addition to and encapsulates the pre-job. The lockout-tagout procedure is designed to safely get the worker up to the work phase where the work may then actually be conducted. The work phase, however, is where the pre-job then takes over and covers work specifics such as your job scope, your job tasks, the hazard assessment, and any safety measures. Once the work phase is complete, then it's time to return to the lockout-tagout procedure so that everything may then be placed back into normal operating conditions. The steps involved in getting everything back into the normal operating conditions are inspection, confirmation, removal, final warning, re-energizing, and then final notice. But before any of this happens, a competent person must first be designated as in charge of this whole lockout-tagout procedure. Absolutely nothing occurs during the scope of a lockout-tagout procedure without this person's express permission, direction, and knowledge. To do so otherwise is a direct violation of the lockout-tagout procedure. In preparing for the lockout-tagout procedure, identify your objective, determine your course of action, and review all available documentation. This documentation can include almost anything, all dependent on what your job scope is. It can include anything from site layout, system schematics, field drawings, customer logs, job prints, previous test results, construction history, what have you. For a simple illustration, we'll use this example here. Let's say we're planning on replacing this obsolete piece of equipment. This will require us to de-energize the equipment, isolate the equipment, remove the equipment, replace the equipment, and finally to re-energize the new equipment. During the shutdown phase, consider all potential energy sources and, if possible, render them to a zero energy state. You cannot assume that a zero energy state exists. It must be confirmed through proven, acceptable, and prescribed test methods. Something that may help is to imagine a bubble surrounding the planned work area, with the goal being to prevent any energies from entering that bubble that could either hurt or kill a worker through their hazardous effects. When planning this out, do not mistake the term energy as only being associated with electricity. Energies requiring lockout-tagout procedures may also include mechanical, hydraulic, pneumatic, chemical, gravity, radiation, process, thermal, stored, and that's just to name a few. In our example here, we've identified electrical and steam as entering our planned work bubble. These are now shut down. The electrical disconnect is opened, and the steam valve is closed. Following this, we conduct a voltage check to verify that the electricity is off and bleed off any residual steam pressure by opening the pressure relief valve. Once confirmed as de-energized, the equipment is then to be effectively isolated from all energy sources. For example, when dealing with electricity, this may require the removal of fuses or jumpers. To establish and to let others know that the equipment has been isolated for worker protection, locks and/or tags must be installed at each of those isolation points to prevent anyone from inadvertently re-energizing the system. Before we go any further, 3 additional points regarding the installation of locks and tags needs to be brought up. Firstly, if locks can be installed, then they must be installed. Tags alone are only permitted where locks cannot be applied. An example of this is that Shepard's hook tagging device used on overhead lines. Second, after having installed the locks and before the work phase begins, you should always try to operate whatever component you just locked out, whether it be a switch, valve, whatnot. If you can still operate that component after the locks have been installed,
then you're doing it wrong.
Those locks are doing no one any good. Now is the time to take the opportunity to save a coworker's life by ensuring that all locking mechanisms have been effectively installed. And finally, Only he who installs a tagged protection is allowed to remove that tagged protection, whether it be a lock, grounds, barricades, etc. This is the key role of those tags. For anyone else to be removing them, it must be well documented beforehand as to who this alternate stand-in is and why they are removing them. Now let's move on. At this point, any additional necessary controls are now implemented to ensure the continuation of a zero energy state. Examples can include personal protective or circuit protective grounds to bleed off residual electrical energy such as induction or to mitigate a worker's exposure to 2 points of electrical contact. Barriers or barricades to prevent unauthorized parties from entering the lockout tagout work area, or it can be as simple as even chocking a piece of equipment, preventing it from rolling, shifting, or moving that could otherwise expose a worker to a caught-between hazard. Once all of this is complete, the competent person in charge must verify that all the previous steps are effective and complete, that a safe working condition has actually been established. The competent person will now review the status, findings, and work parameters with all affected parties involved in this lockout-tagout procedure. It is typically at this point that everyone involved in the lockout-tagout procedure will sign either a crew member record, a red tag master, or the equivalent, acknowledging this information transfer. The work phase may now begin. Here we begin our job scope with all of its associated tasks as documented on the pre-job. In this example, the equipment is dismantled, removed from the site, and new equipment installed. The work phase is now complete. Once completed, the process to get the equipment back into normal operation may now begin. To do this, the competent person in charge inspects to verify that all the intended work has been completed and removes all non-essential items from the work site. The competent person in charge ensures that all employees involved in the lockout-tagout procedure are accounted for, and that all of the employees are updated as to the current status of the lockout-tagout procedure. In other words, that all the work is now complete and things are going to be turned back on. It is typically at this point that all employees again sign the crew member record or the red tag master acknowledging this information transfer. All locks, tags, and any controls that have been installed are now removed. Remember, unless documented otherwise, the only person permitted to remove locks and tags is the person who installed them. The competent person in charge visually verifies that all of these locks, tags, and controls have, in fact, been removed. The competent person informs all employees involved that the system is about to be re-energized. The system is then re-energized, and the competent person informs everyone that all conditions are now back to normal, that the lockout-tagout procedure is complete and no longer in effect.